Hello everyone. Welcome to ComSci Connection. This is going to be a short example of using Eclipse's debugger and also how to use a debugger in general for troubleshooting your code. So a few simple tricks that we'll go through in this video, but I'm going to start out with the basics. What is debug mode and how do you use it? Well, debug mode is basically a way for you to monitor the behavior of your program and actually see every single step that is executed by your code while it's running. In my opinion, debug mode is the most important thing you'll ever learn when you're trying to learn the basics of programming. Really, writing code is a puzzle. You're solving that puzzle over a period of time, and even though the programs might execute quickly and in very minuscule amounts of time, the process of writing the code takes a long time, and sometimes the design of that can be problematic, and that's exactly what debug mode is good for, is to allow you to get to that point where you've got really great, concise code that works and you can verify it. So a lot of you are familiar with the green button right here, which would run my deck shuffler program. We're not going to use that for this video, at least not mainly. Right next to that, you'll see a little picture of a beetle or a bug. It's green as well, but it looks a little bit different. And basically, the behavior of the buttons are the same until you start placing debug points and monitoring the program of your code. Now, what's a debug point? Well, debug point is basically or a breakpoint, in other words, is a place where you want it to stop and wait. So it'll wait for you to tell it to go on to the next step, and you can actually monitor what's going on with your program. So I'm just going to go ahead and show you what happens when I run this code that I've got here. Just as a quick explanation, I guess first, this is a deck shuffler. It's just a simple program I put together. It's only got two methods, shuffle and print. Main just basically initializes cards for simplicity. I'm only using basically one set. I'm not using all 52 cards. It's just, ace up to king. And I just use numerical values just so it would be simple. And then basically it's going to print, it's going to shuffle the cards, and it's going to print them again. So let's see what happens when I run it. Oh man, well, you probably could have seen this coming considering it's a debug example, but we got some bugs in our code. Now, what's interesting is I see this red text, this scary red stuff right here that we can go into depths or into details about what these things mean, but right now what clues me in the most is that it says I've got an exception in main, and then it was an illegal argument exception, and that it happened, and here's why, n must be positive, and it was given from random.nextInt. So the random class threw that exception up, but I can actually see exactly in my own code where this happened. So it says at deckShuffler.shuffle in the method shuffle, and it was line 38. Well, I can click that and it takes me right to it, and I know, just ignore this for now, that was for my memory. But I can see immediately that this is where the problem occurred. But even more interesting, I can see that I've actually got some output, some garbage that happened before that. So let's go ahead, and this is just kind of an exercise on how you might determine where you want to break. So I can see that the problem happened here, but even before that occurred, there's something here that doesn't look quite right. So let's go ahead and comment out these two lines. So obviously I know that shuffle caused this problem, so let's avoid shuffling again, and then we'll go ahead and run it again. So I'm getting this weird printout on the screen. Now, why might that happen? I mean, that's kind of strange, right? I don't really know what's going on there. So I can assume, though, that since print is the only thing I'm doing, let's go ahead and set a breakpoint on print. So I double click on this little this line over here on the left, which basically allows it right now it's highlighting the area that main is in. If I were to select a different method, it's going to highlight the range of that method, just for my own ease, but I can really put a breakpoint wherever I want. I mean, it doesn't really matter. It doesn't like it for you to put them on commented lines because they won't be executed, but even if I have this method selected, I can put a breakpoint here, and that's totally fine. But basically now when I click the debug button, it's going to do the same as it did before, but now it's going to stop when it reaches print. So I can see exactly what's going on here. Well, if I select cards, this is my variable here, it's an array. It knows that it basically represents here that it's an object. Its object has a value, which is an ID of 17. It just basically means that it allows you to keep track. If I had several different int arrays, they would have different IDs, and I could keep track of the same or I keep track of which object I'm actually looking at, because I might have maybe I'd have one for each suit, right? So I might have like jacks. I would have like diamonds and hearts and spades, and each one of them might have 1 through 13. So I want to make sure I'm distinguishing them from the others, and even though so they'll all have the same values, I might use the IDs for that sense. But I can see what values my array has, and that looks normal. That's what I would expect. You know, indexes are numbered from 0 to 12, and the values are 1 to 13. That's normal, and that's pretty much it. So nothing looks out of the ordinary for now, but let's stop and take a look at the buttons that we have available to us to control debug mode. So we've got resume. Well, let's see what happens when I press that. Oh man, I just get that garbage printed, and then it just finished my program. Well, it continued executing, and since I didn't have another breakpoint set, it just finished the program. So it behaved kind of the same way it would when you normally run it. Let's go ahead and debug again. Stop, well, that just terminates execution. One important thing, if you're clicking this a lot, you'll start to notice that it won't always terminate. So you might be used to running your program once and seeing it run and terminate. Well, this will stop and wait at your breakpoints. So if you ever see something like this, where I've got all of these instances of this program running, or if you ever start to notice that your compiler is running slow, like this, I just told it to debug and run another instance of the program, and it's taken forever. It's probably because of all this junk. And you can come in here, if you're in Java View and you're always like, why is it running so slow? I recommend going into debug mode, seeing if you've got other instances of your code running. You can just right click and terminate all. And those are all different instances of the same code that I had running. So now they're all terminated. Let's clear all those out. Let's run it again. Enough of that nonsense. So I've got a couple other ones here. We've got step into and step over, and then also step return, which we can't use right now. Now if I step over, it's going to step over this line, which essentially means it's going to skip it, which means that I get my garbage printed out, and then I'm at the end of the program. That's not what we want to do. So let's step into, and I believe it'll follow us into that print method. Now we can see here pretty simply that we're just trying to print out cards. Well, what is cards? Cards is my array. Well, cards is an object, and I can't really print objects. So this is a pretty simple example, but it basically allowed us to see where the problem was going by stepping in. So we can see that I haven't gotten the garbage output now, but if I step over this line, I get the garbage output. So I know exactly that's where this is happening. Now, for those of you who know, you can't actually print objects to the screen. So I'll just do for each loop here really quickly. For each int I in cards, let's system out print. Let's take out the ln. Let's just do I plus that nonsense. Alright, now let's go ahead and run it again, and we'll see that pretty plainly I've got 1 through 13 being displayed here. So now I know I've fixed that bug. Let's undo these. So that was a pretty simple example, but let's go ahead and run it again in debug mode. It's going to stop there. I'm going to step over this time, and we're at shuffle. Alright, let's step over that. Oh, what's this? Source not found. Well, what this means is that I tried to step over something, and it caused an error. It caused an exception, and it's basically coming from random.nextInt. Well, it's trying to open up that code to show me where the break happened, but since I can't see that code, I don't have access to the random class. That's why I'm getting this edit source lookup not found thing. So that's kind of strange, but let's just close that, and that tells us pretty plainly that we've got a bug here that it couldn't go past. It's this random next int, and it was called at line 41 of deck shuffler. So let's terminate that instance. Let's go ahead and run it again, and let's step over this and then step into shuffle. So I create a new random object. That seems fine. I'm making the size, which is equal to the length of my cards, which is 13. That seems normal. And then what are we doing here? So we're taking our current index, randomizing up to that number. So that'd be 0 to 12. Well, that's right. And then let's see. I'm taking temp, the int value, equals the index of so whatever the randomized number was of my cards thing, and that's basically the random card I'm going to select, which in this case was index 10, which would be value 11. So temp assigned value 11. Now, this seems normal to me, so I'm going to go ahead and put a breakpoint here. No, actually I'm going to put it here at int index, because that seemed to be where my problem was at this random thing, right? So now let's go ahead and let's press resume, and now we're back to the same line. So I resumed, but it started the loop back over, and it reached this point again, so it stopped again. Now we can see that size is highlighted in yellow to illustrate that it was changed. Well, that was because of this size minus minus, and now we're ready to get the next index value, which in this case is 5. So, okay, that seems okay. Well, let's resume. Well, size is 11 now. Let's resume again. Size is 10, 9, 8, 7, 6. Here, let me highlight that to make it a little easier. 5, 4, 3, 2, 1, 0. Okay. Oh. Well, that's weird. So I can't randomize with a 0 value. Well, what exactly am I trying to do here? So it seems like my code is trying to select a random index, save that index, swap the two indexes, so it's going to swap it with basically the last, so the size minus 1, so the last index. It's going to basically place the randomly selected card at the end of my array by swapping the two values, and then it's going to decrement size. So I probably can't do it at 0, right? But let's actually, rather than going and changing my code, let's try something here. Let's redo that, and we'll do the same thing again. So I'm going to go step down until size is 0. Now let's change size to be, alright, come on, let's change size here to be 1. Alright, now let's see what happens. Well, this is a bad example because it's still going to go through and keep hitting 0. So let's just make it, let's break, well, that didn't work. Alright, let me try this again. I'm trying to illustrate a point here and it's not working. Alright, so we're going to get all the way down to 1. Now let's step over this, step over this, step over this, step over this. And then let's make size 0 now. That way it's going to decrement size again, and now size, it won't execute that loop, and okay, that seems to have quit. So that seems to have fixed my problem, or at least potentially fixed my problem. So let's try actually putting in size greater than 0 here and see if maybe that makes it a little better. So let's run it again. Oh, alright, cool. So I didn't get an error that time, but I did have a formatting problem here, so let's just print a blank line after my for loop in that line. Let's try it again. Alright, so here's what I'm getting. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. 1, 2, 3, 1, 2, 2, 5, 8, 7, 3. Well, okay, so I'm not getting a bug anymore. It's not crashing, but that's definitely not right. I mean, why do I have several 2s? What's going wrong with my code here? That's just really weird. So I should probably watch what's happening, right? So let's go ahead and let's set up, well, we've got a breakpoint there already. Let's remove this breakpoint. I don't need it anymore. Let's start a new instance of the debugger. So what am I doing? Let's actually look at this in detail. So right now I'm selecting from size 13 a random index. My index was 5. So it's going to take, so I can actually see 0, 1, 2, 3, 4, 5. Well, that's the value 6. So it's going to take, and this is where debugging helps. You can step through it one at a time. I can see that index is 5 and that cards is this. So the 5th index, if I can scroll down here, nope, alright. So the 5th index is value 6. It's going to store that in a variable called temp. So let's watch that happen. Alright, temp, well, that's value 6, that's good. And then I'm going to take cards of size minus 1. Well, size is currently 13. So size minus 1 would be 12. So index 12 is going to get assigned, which is currently 13, is going to get assigned the value of temp. Well, that's 6, we know that, so put 6 there. But what happened to 13? Oh, what did happen to 13? It just got overwritten, right? Now what am I trying to do? I'm trying to assign the old index equal to card size minus 1. Well, that's this one. We know that. Size minus 1 is 12. So I'm trying to assign the value at the 12th index to the value at the randomized index I have, which is what I just did in reverse, right? So it's the value of 6. Well, that's just going to make it 2 6s. Look, nothing changed. Okay, well that makes perfect sense then. I see exactly what's going on here. I need to reverse the order of these indexes, or these steps. Great. Let's terminate. Let's run it again. This time, just because I'm feeling lucky, let's go ahead and let's actually remove my breakpoint and hit resume. Now what happens here? So I've got 10, 13, 6, 7, 5, 1, 9, 2, 4. That looks pretty okay. I think I've got exactly 13 values. I could step into this to make sure that that's actually behaving the way we want. Oh, yeah, that's right. I have to do this. Okay, step over. Let's collapse this. Temp is 5 again. Temp is the value at index 4, which was the randomized index. So now we're going to take index 4 and assign it to whatever the last card is, which is 13. So cards 1, 2, 3, 4, 13. And then the last index is going to get assigned the current value at temp, which is 5. So I took the 5th card and placed it at the end. And then we're going to decrease the size by 1 so that we don't have that option of the last, so we're not going to mess with this last index anymore. Now we can step over it again. We can see that we're going to take we got an index 0, so temp is 1. We're going to replace those two indexes. So now we've got 12, 2, 3, 4, 13, 1, and 5. Alright, great. Let's decrease size. So we can see that if I were to start hitting resume here, every time I resume, I swap one more index until finally I'm going to get down here to the very bottom. Size is 1, so it exits. So that seems pretty good. Now let's talk one more thing. One more short trick here to finish up the debug video. If I were to realize that I am working with all values of size greater than 0, and I'm randomizing between the size, and then I'm subtracting 1 from size, and subtracting 1 from size, and then subtracting 1 from size at the very end, I'm going to do a trick. And this is what I wrote here. So this is what's called a post increment. Just a side note, if I do plus after size, or I do plus size, what's the difference? Now maybe you've never even seen this one before. Now to clue you in, I can also do this, or that. I can put it before or after. Well, do they do the same thing, or are they different? Well, to answer the question, these two are the same right now. Only when they're on their own line, separate from everything else, they're the same. When you use them in conjunction with other things, they're different. Now, this is called a post increment. And this is called a pre-increment. The difference is exactly what you would think. Size's value is evaluated first. The statements are executed with that value as it currently is, and then when everything else is done, it adds 1 to the value and then moves on to the next line. This is the opposite. This will increment your variable first, then evaluate it, and then continue executing the rest of the statements. So, how can I use that? Well, as I said before, I'm using size to get a random value between 0 and size minus 1, and then I'm subtracting 1, and then I'm subtracting 1 again to actually use the correct index values, and then I'm subtracting 1 officially from size at the very end. Well, why don't I get rid of this and just use size minus right here? Now, let me reiterate what's going to happen. So, it's going to evaluate the right side of the equation first, like it always does. It's going to randomize a next integer from the values 0 up to size minus 1. Well, size is 13. Okay, this is getting confusing, right? Well, let's see it in debug mode. How about that, right? Wouldn't that be so much easier? So size is 13. My index is going to be random from size minus minus. So is it going to send random 13 or is it going to send it 12? Well, I'm not really sure, and it's hard to see, right? We don't really know. So let's go ahead and add another line. Let's do int random num equals this stuff. And then we'll do, wait, no, I want not all that stuff, I want this stuff. Just to make a point. This is getting janky. It's not actually random, so I don't want to call it that. Okay, so now we're going to actually see what happens. So if I hit debug on this line, let's try that again. So right now I've got size is 13. Well, num is going to get assigned to size minus minus. So what is num going to be? 13. Right? So size changed, but num got the value 13. So what actually happened? It evaluated size as 13, assigned it to the value of num, and then once everything was done, it decremented size by 1. Now let's change that and see what happens if I put size minus minus before it. So remember, num got the value 13 even though size was 12 after the statement executed. This time, I think it's going to be different. Size is 13. Let's step over and see that num got 12, while size also updated to 12. So what happened there is that it updated size first to 12 and then assigned the value to num. So this is a pre-increment. It happens before everything else. And this is a post-increment, which happens after everything else. Yes, everything else, even though you're used to arithmetic always happens on the right or whatever, and then the value is assigned to the left as the final thing. Those rules are still true, but this property occurs after everything else on the line is done, including assigning values on the left. So, back to my original point, how can I use this? I can take size minus minus right here. I know that it's going to take it's going to take the current size, so 0 up to size minus 1, decrement that value by 1, and then I can change this to just size, because now I'm referring to the index. And then again, when it starts to loop back over, I don't need a decrement because the decrement has already been done. Just a little fancy trick, but I'm going to show you that this will still behave the exact same way without any issues. So, a little bit of an aside there with post and pre-increments, but it is important stuff. And I think that's everything I wanted to cover. So let us know if you have any questions. Otherwise, I will see you guys next time.